Okay, before we start chapter gravity, we should understand the laws of Newton. There are total 3 laws that are given by the great scientist Newton. Okay, Isaac Newton. Okay, so he was sitting under the tree, and an apple fell down and hit his head. And then he was thinking why the apple fell down, not going anywhere, like upside or outside of the earth, like orbit system and another direction also, but why the apple fell down. So an apple is just a one kind of example of gravity, but this gravity is apply every single thing of the earth, every single object attract it. Okay, so without gravity, we have so many problems. Of course, you might be see in an international space station. There is no gravity. Okay, so there are so many problem in a living. So gravity is most important for every single moment in our life. So it is there already, but this Isaac Newton make us understand that what is gravity. Okay, we will understand about the all terms of gravity. Okay, but here is the notes that we are going to understand. Okay, but before understanding of this, let's make clear somehow the laws of Newton. So there are 3 laws. It is very easy. You are practically doing it every single day. Okay, but it is make you understand that what is it. You are doing it every day. Okay, so let's understand. Okay, so first law is a body will remain at rest or moving at constant velocity. A body is any kind of body. Okay, so it will remain rest. Rest means it still or moving constant velocity unless what? It is acted on by unbalanced force. Okay, so here is the example of this Newton first law. This is the body, pen. So I'm putting it here. Okay, so it remains rest. Yes. Okay, if it's constant moving, then it should constantly moving with its velocity. Okay, unless what? I'm not applying any force. But if acted any unbalanced force, I'm applying force, it's going to be change. Okay, I'm doing this, then it's change. So unless I'm applying anything force, that the body remains still or rest or moving at constant. Moving at constant, I'm give you an example. The solar system, all the planets. Okay, they are moving with constant velocity, even earth also. Okay, there is no any unbalanced force applied, right? But you know that the earth is slightly tilted like this. Why? Because during the earth motion, or you can say orbiting the earth and revolving around the sun, the comet, okay, the big comet hits to the earth. not hits, it's a so many years ago. So it hit to the earth, and because of this force, because of the force applied by the hitting applied on the earth, the axis is going to be some tilted. Okay, so what is this? This is unbalanced force, right? So this is the first law of the Newton. Now let's see the second law. What is this? F is equal to ma. This is a sign of vector. Vector means we are considering as a direction, portion, distance. This all comes in the vector. Directions x, y, z, 3D, 4D, 7D, like that. Not so far, but this is the vector formula. Okay, now F is equal to ma. What does it mean? Okay, F, which is force. F means force. M means mass, weight. Okay, and A means what? Acceleration. Force is equal to or directly proportional to, of course you can also say that. Okay, if it's directly proportional to, then what? F is increased, then mass is also increased, and acceleration is also increased, which is called directly proportional to. And inversely proportional to means what? It comes in a denominator, but here is nothing like denominator. We will see that. Okay, so an object is proportional to what? Mass and acceleration. Okay, I'm giving you an example. Okay, I'm holding this pen and pulling. I don't have any kind of problem, I'm just easily pull this pen, right? Easily hold this pen, or I can moving here there easily. Okay, because the weight is very less. Instead of this I am pulling one wooden dining table. Then what happened? I can not able to do easily. Even I hurt myself, because it's depend on the mass. Okay, if mass is increased, then acceleration is also increased, and acceleration is because of the force. We have to apply more force, right? You already learn in force chapter, right? Mass is more. Okay, then we apply more force to increase the acceleration or increase its speed. Okay, so this is the second law of the Newton. Okay, the force is equal to what? Whenever we apply the force is equal to the object mass and acceleration. If we apply more force, if we require more force, when the mass is more and force is more, then acceleration is going to more also, right? So this is the second law. Now we see the third law. This is very important law in every way. If two body exert means work, a force. I'm talking about two body is any body. Okay, so exert a force, one another forces are equal and opposite of direction. This is very important. Forces are equal and opposite of the direction. What does it mean? Okay, let's see the example. Here is the pen. I'm holding it, I'm pulling it. I don't require any energy of it. Okay, but it is heavy, then require more energy and more force, right? Here is one example, like a space shuttle or a rocket launch. Okay, it is so heavy, you know that, in tons, right? Just because of that propulsions, why it's require explode much? Because it's heavy body, it's require more energy to goes up. What is that? How many tons of rocket is equally and proportional forces apply? So for that force we require more proportional, more fuel, right? Fuel we required as per the weight of the rocket, right? if we are uh, uh, if we are carry one little baby, then we can carry easily, right? But if we are trying to carry a horse or a baby calf, so it's require more energy. So what is this? This is the inverse proportional means opposite. Whatever the forces are equal and opposite direction, what are the mass of the object, it requires same force, same mass to carry it, right? The space shuttle is kind of 10 to 50 tons, for example. Okay, so with respect to that, we require the energy to take off. Okay, rather than what happen is going to be crash or fall down. Okay, another example that we are doing in a simple practically life, that your pet dog, he wants to go another direction and you wants to go another direction, that the string which is you pulling another side and the dog is pulling that opposite side. If the dog is pulling more, then you have to push next side more, right? So this is opposite side. Okay, so this is the three laws of Newton.